Welcome, it is time to slow down and embark on a journey into the universe's greatest silence. Close your eyes and leave the outside world behind. Tonight, we open the doors to infinity. The story you are about to hear is the whisper of the space void itself, the realm of absolute cold and the secrets of science. We will explore the invisible web of dark matter and the distances even light cannot conquer. This space is orderly, immense, and profoundly peaceful. Let my voice and the cosmic rhythm gently attune your mind to the quiet pulse of the universe. Take a deep breath, relax, and listen to the song of the void. The absolute dark, a vast, unending silence. What we call space void is much more than mere emptiness. It is the interstellar medium, a cold, tranquil, and near-perfect vacuum. Its pressure is billions of times lower than Earth's sea-level atmosphere. Yet, this void is not truly empty. It is sparsely populated by clouds of matter, usually just a few atoms per cubic meter. These are mainly hydrogen and helium atoms. These particles travel billions of miles, serving as the raw seeds for the cosmic dust and gas that structure the galaxy. Space is intensely cold, approaching absolute zero. Its average temperature is about 270.45 degrees Celsius, or 2.7 Kelvin. This chill is the residual energy from the Big Bang, known as the cosmic microwave background (CMB) radiation. Running through the void is a massive, unseen structure, gravity. It dictates the shape of everything. The way to massive stars' orbit, a nebula collapses to form a new solar system, or galaxies clustered together is all the work of this invisible force. The void of space is the fastest medium for light travel. Light races through it at almost 299,792 kilometers per second. The light from a star may take thousands or millions of years to reach us. Every star we see is, in fact, a window into the past. The strong magnetic fields of planets and stars create protective shields within the void. They deflect the flow of charged particles known as the solar wind. Earth's magnetic field protects us from this harmful radiation and creates the dazzling dance of the northern aurora borealis and southern lights aurora australis. The greatest mystery of the void is dark matter and dark energy. They are thought to make up about 95% of the universe, yet we cannot directly see them as they barely interact with us. Dark matter is the invisible scaffolding that holds galaxy clusters together. There is no sound in space because there is not enough matter-air molecules to transmit sound vibrations. However, this does not mean it is utterly silent. Radio waves and plasma oscillations produce strange cosmic sounds recorded by scientists. This is the void's own secret song. The void gives us a feeling of infinity. Everything we see when looking up at night is only a tiny fraction of the universe. Even the observable universe is vast, spanning 93 billion light-years, and is continuously expanding. We are all a part of this void. Every atom in our body was once forged inside a massive star and dispersed through this cosmic emptiness. As you drift off to sleep, remember that you are a small, harmonious part of this vast, silent, and orderly void. Find peace. Within the emptiness, there are regions of slight density, nebulae. These are vast clouds of gas and dust, the literal nurseries of stars. Gravity slowly pulls the material together until the pressure is so high that nuclear fusion begins and a new star is born, burning brightly for billions of years. The spectacular death of a massive star is called a supernova. It is the most powerful explosion in the universe. In a flash, the star's material is ejected into the void, seeding the interstellar medium with elements heavier than iron, like gold and uranium. The tiny specks of cosmic dust found in the void are crucial. They shield molecules from harsh radiation and act as surfaces where more complex molecules can form. This dust is essential for the formation of planets and, ultimately, life itself. According to Einstein's theories, the closer you are to a massive object, the slower time passes. In the void, far from intense gravity, time flows at its fastest. But near a black hole, time dilation is extreme. A minute there could be a lifetime on Earth. The expansion of the universe is sometimes called the Hubble flow. It's not that galaxies are moving through the void. It's the void itself, space-time, that is stretching, carrying the galaxies further and further apart from one another. The most extreme endpoints of gravity are black holes. They are regions in the void where gravity is so intense that nothing, not even light, can escape their pull once it crosses the event horizon. They are the silent, invisible giants of the cosmos. Far across the void, we find quasars. These are the incredibly bright, active cores of early galaxies, powered by supermassive black holes feeding on surrounding matter. They can shine hundreds of times brighter than an entire galaxy, illuminating the deepest reaches of the void. On the largest scales, the universe is structured like a sponge. There are vast regions, known as cosmic voids, where there are very few or no galaxies. These voids can be hundreds of millions of light years across, representing the truest emptiness. Our own solar system is surrounded by a vast, spherical shell of icy objects called the Oort cloud. It exists in the deepest part of the void surrounding our Sun, and is the source of many long-period comets that occasionally visit the inner solar system. The void is home to rogue planets that have been ejected from their star systems and now drift alone through interstellar space. They are cold, dark, and possess no stellar light, yet they might still harbor subsurface oceans kept liquid by internal heat. The deepest level of the void is filled with vacuum energy. According to quantum field theory, even perfect emptiness is teeming with virtual particles constantly popping into and out of existence. This tiny, pervasive energy contributes to the universe's expansion. The void is occasionally pierced by gamma-ray bursts (GRBS). These are incredibly powerful, short-lived blasts of energy thought to be caused by the collapse of massive stars or the merger of neutron stars. They are fleeting reminders of the universe's violence. The challenge of traversing the void lies not just in the distance, but in the radiation. Future interstellar spacecraft must shield passengers from high-energy cosmic rays and solar particles encountered during their long, lonely journey between the stars. Attached to the Voyager spacecraft, now sailing through the interstellar void, is the Golden Record. It carries sounds and images from Earth, a message in a bottle cast into the cosmic emptiness, waiting to be found by any potential extraterrestrial civilization. The void is the ultimate canvas of nature. It is where everything happens, yet it is where almost nothing exists. It encourages us to find our quiet place, to appreciate the delicate balance between the swirling cosmos and the profound, peaceful nothingness surrounding it. Sleep well. Beyond our system, the void is speckled with exoplanets orbiting other stars. Thousands have been confirmed, ranging from scorching hot Jupiters to potentially habitable worlds nestled in the Goldilocks zone, where liquid water could exist. In the void, the gravity difference across an object creates tidal forces. Close to a planet, these forces cause ocean tides. Near a black hole, they can stretch matter into a thin stream, a terrifying process known as spaghettification. The void is traversed by high-energy subatomic particles called cosmic rays. They originate from supernovae or distant galaxies and constantly bombard anything in their path. Their energy is so high that they pose a constant risk to unprotected space travel. Massive objects, like galaxy clusters, warp the space around them, causing gravitational lensing. This acts like a giant, natural telescope, bending and magnifying the light from much more distant objects behind them, allowing us to peek further into the void. Embedded within the matter distribution in the void are faint ripples called baryon acoustic oscillations (BAOS). These are relics from sound waves that traveled through the plasma of the early universe, serving as a standard ruler for cosmologists. Just past Neptune, the void holds the Kuiper belt, a vast ring of icy bodies, including dwarf planets like Pluto. This region is a leftover from the solar system's formation and is a deep, dark reservoir of primitive materials. The faint gas and dust between stars is the interstellar medium ISM. It is a dynamic mix of hot, cold, dense, and diffuse regions where stellar winds collide and chemical reactions slowly forge complex molecules over eons. The first atoms to fill the void, just minutes after the Big Bang, were simple hydrogen and helium. All the heavier elements, the oxygen we breathe, the iron in our blood, were later forged in the fiery hearts and explosive deaths of stars. The Event Horizon Telescope is an array of radio dishes that work together to capture the first image of a black hole's shadow. It confirmed that these strange gravitational prisons truly exist deep within the void, around black holes and nascent stars. Swirling gas and dust form accretion disks. As material spirals inward, friction heats it to millions of degrees, causing it to emit intense X-rays and light before it finally vanishes into the abyss. When sun-like stars die, they gently shed their outer layers, creating a beautiful, glowing shell of gas called a planetary nebula. This expelled matter enriches the void, providing the material for future generations of stars and planets. In the void, the region around a star where a planet can sustain liquid water on its surface is the habitable zone. This narrow, precious band is where the temperature is just right, a sweet spot for life as we know it to potentially flourish. Over cosmic time, larger galaxies often consume smaller ones, a process called galactic cannibalism. Our Milky Way is slowly absorbing several smaller satellite galaxies, adding their stars and gas to its ever-growing spiral. In stellar nurseries, young stars, called T-Tauri stars, are still settling down. They are highly volatile, throwing off huge amounts of energy and wind, actively clearing out the residual gas and dust from their immediate void. The feeling of zero gravity or weightlessness experienced in orbit is actually a constant state of freefall. You, the spacecraft, and everything inside are continually falling around the Earth, suspended in the local void. A massive, unseen concentration of mass, dubbed the Great Attractor, is pulling our Milky Way and other galaxies toward it. Its immense gravitational influence dominates a large region of the local void. Hypothetically, wormholes could create shortcuts through the vast void, connecting to different points in spacetime. If stable, they could enable travel across unimaginable distances instantly, bending the rules of the cosmos. As galaxies rush away from us due to the expansion of the void, their light is stretched to longer, redder wavelengths, a phenomenon called redshift. The higher the redshift, the faster and farther away the galaxy is. After a star, like the Sun, exhausts its nuclear fuel, it collapses into a dense, hot cinder called a white dwarf. These fading embers drift through the void, slowly cooling over billions of years until they become cold black dwarfs. Ripples in the fabric of spacetime, called gravitational waves, are generated by violent events like black hole mergers. They travel through the void at the speed of light, carrying information about the cosmos's most extreme physics. The official boundary of our solar system is defined by the heliopause, where the pressure from the solar wind is finally overcome by the pressure of the interstellar medium. Beyond this lies the true galactic void. The coldest, densest parts of the ISM form molecular clouds. Here, hydrogen atoms can pair up to form hydrogen molecules, and complex organic molecules are created, the chemical precursors to life. The very first stars, population 3 stars, were massive and contained only hydrogen and helium. Their lives were short and explosive, but they were essential, enriching the void with the first heavy elements. Dark energy is thought to be the mysterious force accelerating the expansion of the void. It is a uniform energy density that pervades all of space, pushing everything apart against the pull of gravity. Let the vastness of the void fill your thoughts. It is a place of profound physics and infinite scale. Its darkness is not empty, but rich with potential and history. Breathe deeply and allow its silence to bring you rest. The Voyager 1 and 2 probes are humanity's farthest ambassadors, having crossed the heliopause into the interstellar void. They continue to transmit data, sampling the galactic environment beyond our sun's influence. In the dense heart of a nebula, a collapsing clump of gas that has not yet ignited fusion is called a protostar. It pulls in more and more material from the surrounding void, slowly building up the mass required to become a star. Galaxies are not randomly scattered. They are clustered along vast strands of matter called filaments, forming a structure known as the cosmic web. These filaments surround the large, empty cosmic voids. The habitable epoch of the universe began about 10 million years after the Big Bang, once the first stars had enriched the void with heavy elements necessary for building rocky planets and complex chemistry. Over billions of years, the void has witnessed the evolution of galaxies, from irregular, star-forming clumps to the grand, majestic spirals and smooth, ancient ellipticals we observe today. Stars, especially young or small ones, can suddenly erupt with massive bursts of energy called stellar flares. These blasts of radiation and particles are launched into the void, sometimes threatening orbiting planets. At the quantum level, the void is never static. According to the uncertainty principle, there is a constant, unceasing creation and annihilation of virtual particle pairs, a bubbling energy intrinsic to space itself. The space between galaxies is known as intergalactic space. It is even emptier and colder than the interstellar medium, containing almost no matter, making it the closest thing to a perfect vacuum. Each tiny grain of cosmic dust found drifting in the void acts as a tiny reaction chamber, enabling simple atoms to combine into complex, prebiotic molecules that can survive the harsh environment. The void encompasses all extremes: the birth of stars, the death of black holes, and the relentless speed of light. Yet, it offers a calming perspective. Rest now, within the embrace of the vast, quiet cosmos. Jupiter, the largest planet in our system, acts as a cosmic vacuum cleaner in the local void. Its immense gravity has historically swept up or deflected countless comets and asteroids, shielding Earth from major impacts. The rings of gas giants like Saturn are made of countless small particles of ice and rock orbiting in the equatorial plane. They are a temporary structure, constantly being shaped by gravity and stellar wind in the local void. Galaxies are embedded in much larger, invisible spheres of dark matter halos. This dense, unseen mass provides the necessary gravitational pull to hold the rapidly spinning stellar disks together. Occasionally, stars are slingshotted out of their galaxies at extreme speeds, likely due to a close encounter with the central black hole. These hypervelocity stars race alone through the intergalactic void. Stars formed in the early void, known as metal-poor stars population 2, have very little of the heavier elements. Their composition tells astronomers about the chemical evolution of the universe. Our Sun and entire solar system are not static. We are orbiting the center of the Milky Way, spiraling through the galactic void at about 230 kilometers per second, taking 230 million years to complete one lap. Billions of nearly massless, chargeless particles called neutrinos stream through the void and pass right through you every second. They interact so weakly with matter they are often called ghost particles. About 380,000 years after the Big Bang, the void cooled enough for electrons to combine with nuclei, a time called the recombination era. This made the universe transparent, allowing light to travel freely for the first time. Galaxies are grouped into large structures called superclusters. Our Milky Way is part of the Laniakea supercluster, a massive concentration of mass drifting together through the cosmic void. Astronomers measure the huge distances across the void using a series of techniques called the cosmic distance ladder, which uses different types of stars like Cepheid variables as standard mile markers. When certain massive stars die, they leave behind rapidly spinning pulsars, highly magnetized neutron stars that emit beams of radiation. These beams sweep across the void like a lighthouse beacon. The most abundant molecule in the cold void is molecular hydrogen. Although simple, it is notoriously difficult to detect directly, yet it is the primary fuel for star formation. Fate for the void is the Big Freeze. If dark energy continues to dominate, galaxies will accelerate away until the universe is so vast and cold that all matter eventually collapses or decays, leaving only cold emptiness. As small satellite galaxies are torn apart by the Milky Way's gravity, their stars are stretched out into long, thin structures called stellar streams that wrap around a galaxy in the void. The Sun's constant emission of particles and magnetic fields creates space weather. When these phenomena strike Earth's magnetic field, they can disrupt satellites and power grids, a dynamic aspect of the void. The arrow of time in the void is defined by increasing entropy, or disorder. The universe naturally moves from a highly ordered state, the Big Bang, to an increasingly chaotic and spread out state. Our solar system currently resides in a region of the ISM called the local bubble, a giant, low-density cavity in the void carved out by ancient supernova explosions. Comets from the Oort cloud have highly elliptical orbits. They spend most of their existence in the dark, frozen reaches of the void, only briefly swinging into the inner system before retreating again. The actual measured vacuum energy density is vastly smaller than quantum theory predicts. This discrepancy, known as the vacuum catastrophe, is one of the greatest unsolved puzzles of the void. Allow the enormous scale and gentle processes of the void to quiet your mind. Everything is connected, yet separated by immense, calming distances. Let the silence of the cosmos usher you into deep sleep. Some galaxies are powerful emitters of radio waves, often associated with supermassive black holes. These radio galaxies shoot colossal jets of plasma across the intergalactic void. A tiny fraction of a second after the Big Bang, the void underwent a period of incredibly rapid, exponential expansion known as cosmic inflation, smoothing out the universe to its current uniformity. Astronomers refer to all elements heavier than helium as metals. The metallicity of a star, its proportion of these heavier elements, indicates how many cycles of star formation preceded it in the void. The cold environment of the void allows for the formation of surprisingly complex organic molecules, including alcohols and sugars, which are then incorporated into newly forming star systems. The observation that the fundamental constants of physics are precisely tuned to allow for the existence of life suggests the anthropic principle, a profound question about the nature of the void. The heliopause helps shield the inner solar system from the highest energy cosmic rays originating from distant parts of the galaxy, creating a safer pocket within the void. The beautiful spiral arms of galaxies are not fixed structures, but density waves of stars and gas moving through the galactic disk, constantly changing the distribution of mass in the local void. Theory suggests that black holes are not completely black. They slowly lose mass via Hawking radiation, a quantum effect where virtual particles allow the black hole to eventually evaporate back into the void. The Drake equation is a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way, considering factors like the rate of star formation in the void. Even at high speeds, travel between stars in the void takes millennia. The nearest star system, Alpha Centauri, is 4 light-years away, an immense distance requiring patience and revolutionary propulsion. We currently live in the era of stars, where most of the universe's energy is generated by nuclear fusion. This era will end when the supply of hydrogen gas in the void is exhausted. Planets orbiting very close to their stars can become tidally locked, with one side perpetually facing the star and the other facing the cold void, leading to extreme temperature differences. Einstein introduced the cosmological constant to keep the universe static. Ironically, a non-zero value for lambda is now used to describe dark energy's acceleration of the void's expansion. A common type of exoplanet in the void is the super-Earth, a planet more massive than Earth but less massive than Neptune. Their diverse compositions offer clues about planetary formation. The cosmic web structure organizes the void into immense walls of galaxies surrounding enormous, empty voids, like a foam structure across the universe. Spacecraft use the gravitational slingshot maneuver, like using a planet's gravity to boost speed to save fuel and time while traversing the vast, fuel-starved emptiness of the void. The early universe and much of the hot matter today exist as plasma, superheated state of matter where electrons are stripped from nuclei. This plasma dominates many energetic phenomena in the void. The void is continuously undergoing chemical enrichment. Each generation of stars synthesizes heavier elements, which are then scattered by supernovae, ensuring the next generation can form rocky planets. In the profound balance between matter and emptiness, between intense heat and absolute cold, the universe unfolds. You are a part of this perfect, cosmic equilibrium. Drift now into the deep, quiet darkness. Let the scale of the cosmos dwarf your daily worries. The void is endless, and in its silence, there is deep, restoring peace. Close your eyes and enter the quiet. The void, vast and patient, first saw the light of proto-galaxies, small, chaotic clumps of gas, and the earliest stars, beginning to coalesce under the sheer pressure of dark matter. These small systems collided and merged over eons, slowly building the magnificent structures we chart today. This foundational era defined the large-scale architecture of everything we currently observe. The invisible hand of gravity drove this epic cosmic construction. Only about 5% of the total mass energy content of the void is made up of baryonic matter, the atoms that form everything we can touch. A significant fraction of this matter remains hidden, theorized to reside in a hot, diffuse state known as the warm hot intergalactic medium WHIM. This sprawling web of gas connects galaxies and represents one of the final frontiers in accounting for all the missing ordinary matter within the cosmic expanse. Our view of the void is fundamentally constrained by the speed of light. Light from the most distant objects has been traveling for billions of years, meaning we are looking back in time. The edge of the observable universe is the farthest point from which light has had time to reach us. Beyond this horizon lies the rest of the universe, unobservable yet physically real, expanding into an unknown territory that challenges our sense of scale. The void hosts nature's most powerful particle accelerators. Events like supernovae explosions and the accretion disks of black holes launch high-energy particles to near light speed. These ultra-high-energy cosmic rays travel across vast intergalactic distances, providing clues about the extreme physics at play far beyond our solar system. The interaction of these particles permeates all of space. Einstein taught us that the void is not static, but a dynamic, interwoven fabric called spacetime. The presence of mass and energy warps this fabric, which we perceive as gravity. On cosmic scales, the overall geometry of the void is believed to be flat, a critical finding supported by measurements of the cosmic microwave background. While often called a vacuum, the void is defined by constant quantum activity. Even in the emptiest regions, particles momentarily wink into and out of existence, the vacuum fluctuation of quantum fields. This subatomic dance creates a tiny, intrinsic energy that contributes to the mysterious dark energy driving cosmic expansion, making true emptiness a theoretical impossibility. The void is traversed by rogue black holes, stellar remnants ejected from their home galaxies through complex gravitational interactions. These invisible gravitational giants wander silently. Detecting them relies solely on observing their powerful gravitational lensing effects on the light of background stars as they pass directly in front, a rare cosmic alignment that verifies their hidden presence in the vast void. Galaxies maintain their stellar life cycle through the galactic fountain, a process where supernovae explosions push hot gas out into the surrounding void, the halo. This gas cools and eventually rains back down onto the disk, providing fresh fuel for future star formation. This massive recycling system illustrates the dynamic interplay between the galaxy and the surrounding emptiness, ensuring cosmic perpetuity. Deep in the cold, dark molecular clouds of the void, chemistry takes on bizarre forms. Temperatures drop near absolute zero, yet complex interstellar molecules, including various organic compounds like alcohols, form on the surfaces of cosmic dust grains. These chemical factories are essential, as their compounds may deliver the building blocks of life to habitable worlds. The ultimate destiny of the void appears to be an endless, cold expansion. As dark energy continues to dominate gravity, the distance between unbound objects will grow exponentially. Over long timescales, even the nearest galaxies will recede beyond our observable horizon, leaving our local group as an isolated island in an ever-growing, dark, and frigid cosmic ocean. Rest now in this quiet contemplation. Future space travel will rely on the powerful yet silent forces of the void. The gravitational slingshot technique uses a planet's or moon's gravity to change a spacecraft's speed and trajectory without using fuel. It's a cosmic billiard shot, harnessing the motion of massive bodies to accelerate probes across vast, dark distances of the void. This clever maneuver maximizes efficiency in the emptiness. Much of the visible matter in the void, particularly in hot environments like stellar coronas, exists as plasma. This is often called the fourth state of matter, where gas is so hot that electrons are stripped from their atoms. This electrically charged fluid interacts strongly with magnetic fields, driving phenomena like solar flares and galactic jets that influence the surrounding emptiness. The plasma state dominates the high-energy regions of space. The death of an old star can trigger the birth of a new one. Supernova shockwaves ripple through the cold molecular clouds, compressing the gas and dust. This compression initiates gravitational collapse, leading to the formation of protostars. The explosive end of one stellar life seeds the necessary conditions for dozens of new suns to ignite within the surrounding gas. The study of the void includes astrobiology, the search for life beyond Earth. Scientists focus on places that offer liquid water, like the subsurface oceans of icy moons such as Europa or Enceladus, or exoplanets in the habitable zone. These pockets of potential life are islands of warmth and chemistry in the cold, vast, and otherwise sterile cosmic void. The void hosts stars of incredible size, known as hypergiants. These are the largest, most luminous, and most unstable stars known. They burn through their fuel at an astonishing rate, living short, volatile lives before collapsing or exploding dramatically. Their powerful stellar winds constantly push vast amounts of matter out into the interstellar medium, enriching the void. The universe's age is precisely measured at about 13.8 billion years. This is calculated by observing the expansion rate of the void and the characteristics of the cosmic microwave background CMB radiation. The void itself serves as the clock face, with its ongoing expansion providing the ticking mechanism for cosmic timekeeping. While cosmic dust seems insignificant, it plays a vital protective role in the cold molecular clouds. Dust grains absorb ultraviolet radiation, shielding fragile molecules from being destroyed by harsh stellar energy. This creates the necessary dark and cool environment where complex prebiotic chemistry can safely take place before the molecules settle onto a new planet. Occasionally, objects not bound to any star, like the interstellar comets Oumuamua and Borisov, pass through our solar system's neighborhood. These interstellar voyages are ejected from distant star systems and drift for billions of years through the galactic void, offering a rare opportunity to sample material from outside our sun's gravitational influence. Every star system occupies a small sphere of influence in the void, defined by its gravity. The space within this sphere is dominated by the star's pull and light, but beyond it lies the true interstellar medium. The sun's sphere of influence extends far beyond Pluto, encompassing the vast Oort cloud before dissolving into the galactic ocean. As you listen, recognize that the void is not hostile, but perfectly balanced. Its darkness provides protection, its silence offers contemplation, and its cold reminds us of the warmth found in structure. Let this infinite, silent expanse carry you into a deep and restorative sleep. The cosmos holds you gently in its vast, empty arms. The void is not perfectly static. Our own Milky Way is on a collision course with the Andromeda Galaxy. In about 4 billion years, these two giants will meet. They will not crash violently, but their stars will dance and merge, eventually forming a new, larger elliptical galaxy, often nicknamed Milkomeda. This slow, inevitable gravitational embrace is one of the grandest events pre-programmed into the cosmic emptiness. Supermassive black holes, while consuming matter, can launch highly collimated beams of plasma known as relativistic jets across hundreds of thousands of light-years into the void. These jets travel at nearly the speed of light and are among the most energetic phenomena in the universe. They are created near the black hole's poles, carrying vast amounts of energy far out into the cooler intergalactic emptiness. The vast emptiness is permeated by a faint radio signal, the cosmic microwave background (CMB). This radiation is the residual heat signature from the Big Bang, a snapshot of the universe when it was only 380,000 years old. It confirms the universe started hot and dense, and its evenness across the void highlights the initial uniformity of space. Stars can only fuse elements up to ion fusion. Beyond ion requires energy rather than releasing it, marking the end of a star's stable life. When an ion core forms, the star collapses instantly, exploding into a supernova and scattering heavier elements like gold and platinum into the void. This dramatic end is essential for enriching the cosmic environment for future life. Water, the essential ingredient for life, is abundant in the void. It exists primarily as ice grains coating cosmic dust particles in the cold molecular clouds. This ice is then incorporated into planet-forming disks, eventually becoming the oceans and comets of new systems. The quiet presence of water ice throughout the emptiness connects distant nebulae to the rivers on our home world. Astronomers classify stars based on their temperature and color in the void. From the hottest, blue O-type stars down to the cool, red M-type dwarf stars, this classification system OB, F, G, K, and helps predict a star's lifespan and its fate. This stellar taxonomy allows us to understand the vast diversity of energy sources scattered across the emptiness. The continuous stream of charged particles emitted by the sun is the solar wind. It fills the inner void of our solar system, creating the heliosphere. This wind interacts with planetary atmospheres, causing phenomena like auroras and stripping away light elements over billions of years. The solar wind is the breath of our star, constantly shaping the local cosmic environment. Early in a system's life, planets don't always stay where they formed. Planetary migration, often driven by gravitational interaction with the gas disk, causes gas giants to move inward or outward, completely restructuring the arrangement of bodies in the local void. This chaotic dance is necessary to reach the stable, organized orbits we observe today. Astrobiology posits the concept of the great filter, a massive evolutionary hurdle that life must overcome. If the filter lies behind us like the genesis of life, the void may be full of simple life. If it lies ahead like self-destruction, the void is likely barren. This thought experiment reflects humanity's fragile place within the vast, silent possibilities of the cosmos. Every photon hitting your eye from a star has traveled a vast distance through the void. You are not just seeing light, you are seeing the past. The void serves as the universe's ultimate time capsule, faithfully preserving the state of distant objects for millennia. Look up and see not the present, but a frozen moment from history. An interesting, though non-physical, rule of thumb for planetary spacing is the Titius-Bode law. While it has no solid physical basis, it surprisingly predicted the locations of several planets and the asteroid belt within the void of our solar system. This numerological curiosity suggests subtle patterns may exist even in the seemingly random distribution of matter. Light traveling out of a strong gravitational field, such as from a dense star or black hole, loses energy and is shifted to redder wavelengths, a phenomenon called gravitational redshift. The void itself is immune to this effect, but its objects are not, meaning gravity can silently steal energy from light as it travels. Moments after the Big Bang, the void was filled with an incredibly hot, dense soup called quark-gluon plasma. In this state, the fundamental particles quarks were not yet bounding to protons and neutrons, marking a key phase transition. This primordial chaos eventually cooled to form the stable atoms that fill the universe now. When a star passes too close to a supermassive black hole in the galactic void, the hole's extreme tidal forces can tear the star apart, a tidal disruption event. The stellar material spirals in, creating a powerful, temporary flare of light before it vanishes into the abyss. It is a stunning display of gravity's destructive power. Observing the light of a distant star passing through an exoplanet's atmosphere allows scientists to analyze its chemical composition. Detecting biosignatures, like oxygen and methane, is the primary method for searching for life in the vast void. This spectral analysis is our quiet, patient way of listening for the chemistry of alien life. The region around a galaxy where conditions are suitable for life, stable enough for long-lived stars and enriched enough with heavy elements, is sometimes called the galactic habitable shell, a precious zone within the void. Our solar system resides in a quiet, stable part of the Milky Way, ideally suited for prolonged evolution. Vast and metinth local void surrounding Earth is becoming cluttered with space debris, spent rocket stages, inactive satellites, and fragments from collisions. This orbital junk poses a growing risk to active satellites and future missions. Even the pristine emptiness immediately around our planet is slowly being contaminated by human activity. The collision of two neutron stars is a cataclysmic event that generates massive amounts of gravitational waves and is the primary source for the universe's heaviest elements, like gold and platinum, scattering them into the void. These events ensure that elements prized on Earth are synthesized by the violence of the cosmos. The cosmological principle states that on large scales, the void is both homogeneous, the same everywhere, and isotropic, looks the same in every direction. This underlies most modern cosmological models. While local chaos exists, the universe as a whole maintains a perfect, large-scale order that simplifies our understanding of its evolution. Feel the magnitude of the void, but do not let it overwhelm you. It is a system of perfect order and quiet continuity. Let the silent, unhurried pace of the cosmos replace your worries. Find peace and certainty in this immense, unchanging scale. The moment when matter and radiation decoupled, allowing photons to travel freely, occurred about 380,000 years after the Big Bang. This event created the CMB and essentially ended the opaque, plasma-dominated era of the void. Before this, the universe was an impenetrable fog. After, it was revealed in light. Meteor showers occur when Earth passes through the orbital path of a comet, encountering the trail of dust and debris left behind in the solar void. The debris burns up in our atmosphere, creating ephemeral streaks of light. These celestial fireworks are remnants of icy bodies that have traveled far from the Sun. The unexplained clustering of the orbits of distant Kuiper belt objects suggests the possible presence of a large, unseen planet, dubbed Planet 9, orbiting far in the extreme reaches of the solar system's cold void. Its existence, if confirmed, would reshape our map of the Sun's outermost gravitational influence. Hypothetical one-dimensional topological defects in spacetime, called cosmic strings, may have formed during the early universe. While unconfirmed, these theoretical remnants could generate gravitational waves as they vibrate through the void. They are phantom structures, remnants of a universe still cooling and settling its physical laws. The overall orbital plane of the major planets is called the ecliptic. However, the Sun's rotation axis is tilted by about 7 degrees relative to this plane, a fact that hints at violent gravitational influences in the system's distant past, perhaps a collision that altered the alignment of our star. There is an upper mass limit for stars, around 150 solar masses. Beyond this, the star generates so much energy that its own radiation pressure blows away its outer layers, preventing it from gathering more material from the surrounding void. The star essentially self-regulates its size through its own fierce output. Telescopes like Hubble and James Webb, operating in the void above Earth's atmosphere, avoid distortions caused by air, water vapor, and light pollution. This allows them to capture the sharpest images of distant galaxies and nebulae, offering an unobstructed window into the deep emptiness of space. The Kepler Space Telescope spent years staring at one small patch of the void, discovering thousands of exoplanets using the transit method, proving that planets are common throughout the galaxy. Its quiet, persistent observation forever changed our perception of our place in the void. Science fiction concepts like warp drives and hyperspace offer hypothetical ways to bypass the speed limit of light by mathematically distorting or folding the fabric of spacetime, creating shortcuts through the vast cosmic void. These concepts represent humanity's dream of overcoming the immense distances that separate the stars. The cosmological horizon refers to the maximum distance from which particles have had time to reach an observer since the beginning of the universe. Beyond this distance, regions of the void are permanently hidden from our view, separated from us by the accelerating expansion of space itself. Ring galaxies are formed when a small galaxy crashes directly through the center of a large disk galaxy. The shock wave of the collision compresses the gas, creating a circular wave of intense star formation that expands into the void. It is a stunning, but rare, illustration of cosmic billiards on a grand scale. When stars die, their cores are supported against gravitational collapse by degeneracy pressure, a quantum mechanical effect. This force prevents white dwarfs and neutron stars from collapsing further, holding the stellar corpse in eternal equilibrium in the void. In about 5 billion years, the Sun will expand into a red giant, engulfing Mercury, Venus, and possibly Earth. Its outer layers will then drift into the void, forming a beautiful planetary nebula, leaving behind a white dwarf remnant. This quiet, spectacular death awaits our star. The albedo of a planet's surface is crucial for its temperature. An icy planet reflects more light back into the void, staying cold, while a rocky, dark planet absorbs more light, becoming warmer. This delicate balance of light and darkness dictates a world's climate. Some observations once suggested that galaxy clusters were moving collectively toward a single, massive point beyond the observable void, a hypothetical phenomenon called dark flow. This concept, though highly disputed, reminds us that massive, unseen gravitational forces are always at work, governing motion across the emptiness. Humanity's curiosity drives us to send probes into the void. Missions like Cassini and Juno have navigated the gravity and radiation fields, sending back incredible data about distant worlds and their environments. These tireless metallic messengers silently explore the cosmos for us. Our cosmic address is nested within the void: Earth, Solar System, Orion Arm, Milky Way Galaxy, Local Group, Virgo Supercluster, Laniakea Supercluster. Each level is an island of matter within a sea of emptiness, a meticulously structured hierarchy of existence. New stars are born surrounded by circumstellar disks of gas and dust. It is within these disks, orbiting the new star in the local void, that planets eventually accrete and form through countless collisions. These flattened spirals are the construction sites of new worlds. The void holds no memory of our daily anxieties. It is a realm of physics and time, unconcerned with immediate concerns. Let your worries dissolve into the infinite depth of the cosmic darkness. Sleep deeply now, embraced by the absolute calm. High-energy events in the void, such as pulsars and black hole jets, emit gamma rays. Telescopes like the Fermi Gamma Ray Space Telescope observe this light, revealing the most violent and energetic processes of the universe. Gamma rays are the short, sharp voice of cosmic destruction and creation. In a planetary forming disk, the frost line is the distance from the star where volatile compounds like water and methane can condense into solid ice. This boundary dictates the composition of forming planets' rocky inside, icy outside, a crucial architectural line in the void. The identity of dark matter remains unknown. Potential candidates include WIMPs, axions, or primordial black holes. Scientists search for faint interactions between these particles and normal matter in the void, hunting for the substance that secretly binds the galaxies. The period when the very first stars and quasars began to form, ionizing the neutral hydrogen gas that filled the void after the CMB era, is known as the Cosmic Dawn. This marked the end of the universe's dark ages, as light flooded the emptiness for the first time since the Big Bang. When two orbiting bodies have periods that are simple integer ratios, they are in orbital resonance. This can stabilize or destabilize their paths, defining the long-term architecture of a system in the void. Resonance is the quiet music of planetary motion. Extremely hot gas, often found in galaxy clusters or around black holes, emits X-rays into the void. X-ray telescopes are essential for mapping the distribution and temperature of this high-energy, high-temperature matter, revealing where the energy of the void concentrates. The hypothesis of panspermia suggests that microbial life could survive the journey through the cold, harsh void by traveling on asteroids or comets, potentially seeding life from one planetary system to another. Life, under this theory, is not fragile, but a persistent traveler in the emptiness. The Sloan Great Wall is one of the largest known structures in the observable void, a massive filament of galaxy superclusters spanning over 1 billion light-years, demonstrating the universe's immense foam-like structure. This great wall of matter emphasizes the colossal scale of cosmic organization. The void is a dangerous place for unprotected hardware. Spacecraft must be designed to withstand extreme temperature fluctuations, hard vacuum, solar radiation, and the erosion caused by constant micrometeoroid impacts. The stillness of space hides these harsh environmental realities. The cosmos conducts its work with perfect, unhurried regularity. The movement of planets, the turning of galaxies, the expansion of the void all occur with a sublime, eternal calm. Absorb this tranquility and sleep, knowing the universe is in no rush. A rotating black hole is called a K-black hole. Rotation introduces an additional factor into the spacetime geometry, creating a region around the horizon called the ergosphere, from which energy can theoretically be extracted. This swirling vortex is one of the most complex gravitational structures in the void. By studying the oldest stars and globular clusters, astronomers engage in galactic archaeology, piecing together the formation and merger history of the Milky Way, understanding how it evolved within the surrounding void. These old stars are fossils, telling the story of our galaxy's youth. Future interstellar spacecraft might use powerful plasma shields, artificially generated magnetic fields to deflect high-energy cosmic rays, protecting both electronics and human passengers during long voyages through the void. Technology may one day tame the invisible dangers of emptiness. A star's color is a direct indicator of its surface temperature in the void. Blue stars are the hottest up to 50,000 Kelvin, white stars are moderate sun, 6,000 K, and red stars are the coolest 3,000 K. This simple light spectrum reveals the core power of every burning sun. Saturn's rings are separated by large gaps, the most prominent being the Cassini division. These gaps are created by the gravitational forces of the moons, which shepherd the ring particles into distinct, confined orbits. The moons quietly sculpt the fragile beauty floating in the local void. The concept of cosmic horizons reminds us that due to the accelerating expansion of the void, light emitted from galaxies beyond a certain distance will eventually never be able to reach us, making them permanently invisible. We are living in a universe that is slowly pulling away from its distant parts. Asteroids wandering the solar void are categorized by their composition: C-type carbonaceous, dark, S-type siliceous, stony, and N-type metallic, Nicolaian. This diversity reflects where they formed relative to the Sun, holding clues about the chemical map of our early system. Cosmology predicts a certain abundance of lithium from the Big Bang. However, the observed amount in the void is about 3 times less than predicted. The lithium problem, a subtle discrepancy in our understanding of early universe nucleosynthesis. The cosmos holds silent disagreements with our best theories. A star maintains its stability against the crushing force of its own gravity through hydrostatic equilibrium. The outward pressure from the heat of nuclear fusion perfectly balances the inward pull of gravity. This perfect balance ensures a star shines steadily for billions of years in the void. The depth of silence. Close your eyes and let the physical silence of the void wash over you. It is a silence so profound that it carries the echoes of creation. Let this depth of calm settle your thoughts and lead you into rest. There is nothing to hear but the sound of your own peace. The Sloan Digital Sky Survey SDSS has mapped the positions and light of millions of galaxies, creating a detailed 3D map of the structures and clustering within a huge section of the observable void. It is humanity's most ambitious attempt to chart the vastness we inhabit. The very center of the Milky Way is a densely packed, violent region of the void containing a supermassive black hole, Sagittarius, surrounded by dense star clusters and massive amounts of turbulent gas. It is the energetic, powerful heart around which all our local stars revolve. While orbiting planets do not experience gravity in the traditional sense, they still exhibit gravitropism, a growth response to gravity. This is essential for plants that are being grown in confined habitats in the void, instinctively knowing which way is down, even when weightless. Our Sun travels through the void at around 230 kilometers per second as it orbits the galactic center, completing one lap every 230 million years, a cosmic year. We are always in motion, swept along by the invisible rotation of the galaxy. The Moon is slowly but constantly moving away from Earth, causing its orbital period to increase, a process called tidal acceleration, driven by the gravitational interaction between the two bodies in the local void. Our cosmic companion is silently retreating over eons. After the cosmic dawn, the young universe entered the reionization era as radiation from the first stars and quasars stripped electrons from neutral hydrogen, clearing the opaque fog and making the void fully transparent again. The vast universe became visible, ready for light to travel freely. The Hubble constant is the proportionality constant that describes the current rate of expansion of the void. Discrepancies in its measurement point to potential new physics beyond current models. suggesting we may not yet fully grasp the nature of space's growth. Starburst galaxies are undergoing an exceptionally high rate of star formation, consuming their gas reserves rapidly. This intense activity often happens when two galaxies collide, mixing and compressing the gas in the void. They burn brightly but briefly, fueling rapid creation. Future long-duration missions through the void may employ artificial gravity, usually created by rotating the spacecraft to simulate the centrifugal force, preventing the health issues associated with prolonged weightlessness. Technology seeks to recreate the familiar comfort of gravity in the deep emptiness. Surrender to the dark. The void is eternal and infinite. There is no need to fight the current of time or thought. Surrender your awareness to the enveloping darkness and let the profound, steady rhythm of the universe carry you to sleep. When a planet forms, its internal structure undergoes differentiation, where denser materials like iron sink to the core, while lighter materials like silicates float to the surface, creating layers in the planetary body. This segregation is gravity's way of organizing a newborn world. The zodiacal light is a faint, conical glow seen along the ecliptic, caused by sunlight scattering off tiny dust particles orbiting the sun in the plane of the planets, debris left over from comets and asteroids. It is the ghostly sunlight reflecting off the debris field of our system. The galactic bulge is the dense, spheroidal structure at the very heart of the Milky Way. It is mainly composed of older, redder stars and is the gravitational anchor for the entire spiral structure in the void. It is the ancient, stable core of our rotating home. The Drake equation is a probabilistic framework used to estimate the number of active, communicating extraterrestrial civilizations in the Milky Way, considering factors like the rate of suitable planet formation in the void. It is a mathematical expression of cosmic hope and uncertainty. Objects that are moving too fast to be gravitationally bound to a central body, such as some interstellar comets, follow a non-repeating hyperbolic trajectory through the void, entering and then leaving the system forever. They are cosmic transients, passing through once and never returning. Objects moving through the cosmic void, even the sparse interstellar medium, experience gravitational drag, a slight slowing effect caused by the gravity of the dispersed gas and dust particles. This subtle friction affects all motion over vast timescales. As the Voyager probes travel through the interstellar void, their power output from radioisotope thermoelectric generators, RTGs, is slowly declining, meaning their ability to communicate across the vast distance is limited. They will eventually become silent, enduring monuments to human curiosity. Globular clusters are ancient, dense, spherical collections of millions of stars orbiting the outer halo of a galaxy. They are remnants from the galaxy's earliest formation stages, drifting in the surrounding void, pristine fossils from cosmic youth. The theoretical principle of cosmic censorship suggests that every black hole singularity must be hidden behind an event horizon, preventing naked singularities that could expose strange physics directly to the observable void. The universe, it seems, maintains a certain level of modesty at its deepest secrets. Final piece. The void is the ultimate constant, silent, vast, and governed by perfect laws. Let its scale give you perspective and its peace give you rest. Your journey through the cosmos is complete for now. Sleep deeply and let the silence fill your dreams. The void is home to vast clouds of free-floating electrons, remnants of supernovae explosions. These massive electron clouds, sometimes associated with magnetar flares, can briefly dominate regions of space, interacting intensely with the local magnetic fields and producing brilliant bursts of energy that ripple across light years. These high-energy phenomena ensure that even the darkest corners of the cosmos are subject to sudden, powerful electrical forces. The concept of cosmic inflation suggests that the void underwent a period of extremely rapid, exponential expansion just a fraction of a second after the Big Bang. This sudden, Violent growth smoothed out initial irregularities and accounts for the remarkable homogeneity we observe in the universe today. Inflation remains the leading theory explaining why the universe is so uniform across its vast, observable expanse. In the deep void, away from stellar light, the absolute darkness is only slightly mitigated by the faint, all-pervasive glow of the integrated starlight from all the galaxies combined. It is a barely perceptible, ethereal light, the collective shimmer of billions of suns across billions of years. This distant, quiet illumination means that, technically, there is no place in the cosmos that is ever truly 100% dark. The heliosheath is the outermost layer of the heliosphere, a turbulent region where the solar wind is dramatically slowed down by the pressure of the interstellar medium. This vast, warm boundary is the final buffer zone between the gravitational and magnetic influence of our Sun and the truly cold, true galactic void beyond. It is the last frontier of our solar neighborhood. Chemically peculiar stars exist in the void, possessing surface layers with highly unusual abundances of certain elements like manganese, mercury, or silicon. These strange chemical signatures offer crucial clues about their formation environments, gravitational settling processes, and internal mixing dynamics, representing a fascinating anomaly in stellar evolution. The TESS mission transiting exoplanet survey satellite searches the entire sky, systematically monitoring the brightness of hundreds of thousands of nearby stars. It seeks tiny, periodic dips in stellar light caused by planets crossing their faces, furthering our census of worlds and their prevalence throughout the galactic void. TESS is our tireless eye, confirming that planets are the rule, not the exception. The formation of spiral arms in galaxies is thought to be caused by density waves regions of compression that propagate through the stellar disk. These waves momentarily compress gas and trigger intense bursts of star formation, maintaining the beautiful, sweeping, yet transient structure of the galaxy. The arms are not fixed, they are patterns moving through the stellar field. Quark stars are hypothetical, extremely dense objects that could form after a supernova, composed not of neutrons, but of fundamental particles known as quarks. They represent one of the most exotic, compressed, and strange states of matter imaginable in the void, where the normal rules of atomic structure completely break down under immense pressure. The void is constantly being measured using standard candles objects like Type Ia supernovae, which have a known and reliable intrinsic brightness. By carefully comparing their observed, faint light to their known luminosity, astronomers can accurately gauge distances across vast emptiness, linking our local neighborhood to the farthest visible galaxies. Let your body relax into the absolute weightlessness of deep sleep. The powerful cosmic forces of gravity, dark energy, and expansion continue their quiet, massive work, unconcerned with your day's concerns. Surrender your control to the steady, unhurried rhythm of the universe and allow rest to find you now. Interstellar dust particles, though minuscule, carry an electric charge. Their movement is highly influenced by the weak but pervasive magnetic fields permeating the void, causing them to align and interact in complex ways that affect polarized light passing through them. These tiny grains are the dynamic mediators of galactic light. The theoretical concept of a Dyson sphere involves constructing a massive megastructure completely encompassing a star to capture all of its emitted energy. Searching for the unique infrared heat signature of such a structure is one of the primary methods used in the search for advanced, technologically capable alien civilizations in the galactic void. Open star clusters are groups of a few hundred to a few thousand stars that form simultaneously from the same giant molecular cloud. They are loosely bound by gravity and, due to external gravitational tidal forces, gradually disperse into the galactic void over hundreds of millions of years, dissolving into the general stellar population. The existence of dark energy is inferred primarily from the crucial observation that distant Type Ia supernovae appear dimmer than standard expectations allow. This critical cosmological finding implies that the expansion of the void is not slowing down, but is, in fact, accelerating, pulling objects away from us faster and faster. The event horizon of a black hole defines the precise boundary where the escape velocity is equal to the speed of light. Anything that crosses this point, even light itself, is permanently removed from the observable universe, swallowed forever by the singularity. It is the ultimate one-way membrane in the void. Tidal forces are directly responsible for the extreme internal heating of Jupiter's moon Io, making it the most volcanically active world in the solar system. Io's interior is constantly and violently kneaded by the immense, differential gravitational pull of Jupiter and its other large sibling moons. In the local void around massive planets, a plasma torus is a ring of superheated, charged particles surrounding the body. Jupiter's moon Io, through its intense volcanism, supplies massive amounts of sulfur and oxygen ions to form a prominent and glowing torus around the gas giant, an energetic local feature. The Sun's coronal mass ejections launch massive, magnetized bubbles of plasma and magnetic field into the solar void. When these CMS impact Earth, they can cause powerful geomagnetic storms, disrupting technology and producing spectacular, visible auroras at high latitudes. The habitable zone is often subdivided for more precision. The wet habitable zone refers to where surface liquid water can be stable, while the inner habitable zone defines the limit before water vaporizes completely. Defining these boundaries is crucial for life's potential in the void. Let the vast, structured silence of the cosmos permeate your mind entirely. The endless patterns of motion and rest, light and dark, provide a perfect anchor for your thoughts. Drift now, suspended effortlessly between the quiet, eternal stars. The baryon acoustic oscillations are subtle, relic ripples embedded in the large-scale distribution of matter throughout the void. These fossil sound waves from the early, dense universe provide a precise ruler for cosmologists to measure the geometry and expansion history of the cosmos. Hypervelocity stars are stars traveling through the void at such high speeds, often over 1,000 kilometers per second, that they are gravitationally unbound by the galaxy's pull. Most are theorized to be violently ejected by close encounters with the supermassive black hole at the galactic center. The magnetopause is the complex boundary in the void where the Earth's magnetic field meets the onslaught of the solar wind. This dynamic barrier constantly flexes and shifts, acting as a critical, life-sustaining shield that protects our atmosphere from being slowly stripped away by stellar particles. The process of accretion is fundamental to structure formation in the void. It describes how small particles and clumps of matter gradually stick together due to gravity or electrostatic forces, forming asteroids, planets, stars, and eventually, the massive black holes at galactic centers. The extreme density of a neutron star means that a sugar cube's worth of its material would weigh billions of tons. These incredibly dense remnants of massive stars are laboratories of exotic physics, silently spinning in the galactic void and challenging our understanding of matter. Tidal locking causes one side of a moon or planet to perpetually face its host body. Our own moon is tidally locked to Earth, showing us only one face as it silently orbits through the local void. This happens when the gravitational difference across the body slows its rotation over ends. The void is permeated by vast numbers of neutrinos, which are almost massless and electrically neutral particles. They stream through all matter, including your body, the Earth, and the Sun, largely undetected, earning them the nickname ghost particles of the cosmos. The kilonova is an explosive event resulting from the merger of two neutron stars or a neutron star and a black hole. These events are crucial as they synthesize and scatter the universe's heaviest elements, including gold and platinum, throughout the void. The concept of dark matter halos suggests that galaxies are embedded in much larger, invisible spheres of dark matter. This dense, Unseen mass provides the necessary gravitational scaffolding and pull to hold the rapidly spinning stellar and gas disks together in the void. Find your center in the profound stillness of the universe. The vastness of the void reflects a deep, enduring peace that is not easily disturbed. Let the silence become a gentle current that pulls you toward complete relaxation and the restorative peace of sleep. Cosmic voids are the largest known structures in the universe, defined by the almost complete absence of galaxies and galaxy clusters. These enormous bubbles of emptiness occupy most of the volume of the observable universe, existing between the dense walls and filaments of the cosmic web. The great attractor is a massive, mysterious concentration of mass toward which our Milky Way, the local group, and the entire Laniakea supercluster are being pulled at millions of miles per hour. Its precise nature is still largely unknown, but its immense gravitational influence dominates a massive region of the local void. The asteroid belt is a torus-shaped region in the solar void between Mars and Jupiter. It is filled with thousands of small, irregularly shaped rocky bodies, remnants of a planet that failed to fully form due to Jupiter's immense, disruptive gravitational influence. The Lyman Alpha Forest is a characteristic series of absorption lines in the spectra of distant quasars, caused by the light passing through numerous intervening clouds of neutral hydrogen gas scattered throughout the void. It provides a unique map of primordial gas distribution. Molecular hydrogen is the single most abundant molecule in the cold void, yet it is notoriously difficult to detect directly. Its presence is usually inferred by observing the trace amounts of carbon monoxide it is associated with, which acts as a convenient tracer molecule for star formation fuel. The habitable epoch refers to the extended time period in cosmic history when physical conditions were suitable for complex life to exist. This epoch began after the first stars had enriched the void with the necessary heavy elements. The Oort cloud is a vast, spherical shell of icy debris surrounding our solar system, marking the outermost extent of the Sun's gravitational influence. It is the distant, cold source of long-period comets that occasionally plunge into the inner void. Fast radio bursts are mysterious, incredibly powerful radio wave pulses lasting only a few milliseconds, originating from distant galaxies scattered in the void. Their exact source is still highly debated, but they are among the most energetic and brief signals in the cosmos. The concept of the no-hair theorem suggests that once a black hole settles down, its external characteristics are limited to just three observable properties: its mass, its electric charge, and its angular momentum spin. All other details about the swallowed matter are lost to the void. Let your consciousness drift away from the immediate details of the day. Focus only on the vast, continuous flow of the cosmos, where every event, from the smallest particle dance to the largest galactic merger, proceeds with quiet certainty and profound order. The Sun's heliopause marks the precise boundary in the void where the pressure of the solar wind is no longer strong enough to push back the interstellar medium. Beyond this turbulent, transitional boundary lies true interstellar space, a region only reached by the Voyager probes. Tauri stars are pre-main sequence stars, still undergoing gravitational contraction and not yet burning hydrogen in their cores. They are highly variable and often throw off massive stellar winds, actively clearing the residual gas and dust from their local void. The presence of complex organic molecules in meteorites and comets suggests that the chemical building blocks of life are readily synthesized in the cold, unpressured environment of the void and routinely delivered to young, forming planets. Primordial black holes are hypothetical objects that may have formed in the chaotic, high-density environment of the early universe instead of collapsing from massive stars. If numerous enough, they could constitute a significant and mysterious fraction of the universe's dark matter. The cosmic distance ladder is a comprehensive sequence of measurement techniques used to determine the distance to far-flung objects in the void. It starts with simple geometric measurements and uses each step to precisely calibrate the next, reaching across billions of light years. The interstellar extinction is the observable dimming and reddening of starlight as it passes through sparse interstellar dust and gas in the void. This measurable effect must be carefully accounted for by astronomers when determining the true brightness and temperature of distant stars. Pulsars are rapidly spinning neutron stars that emit highly focused beams of electromagnetic radiation. These beams sweep across the void like a lighthouse beam as the neutron star rotates. If the beam crosses Earth, we detect it as a regular, incredibly precise pulse. The local bubble is a large, low-density cavity in the interstellar medium, about 300 light-years wide, in which our solar system currently resides. It was created by ancient, powerful supernova explosions that swept gas out of our local region of the void. The Carrington event was a massive solar storm in 1859 that released a huge coronal mass ejection directly at Earth. It caused auroras visible near the equator and demonstrated the profound and sometimes violent effect of the solar void on our planet's technological systems. Let the thought of endless, vast space bring a deep and profound calm. The universe is too enormous for small, immediate worries. Embrace the profound, rhythmic stillness that underlies all motion in the void. Sleep comes easily when the mind is at peace. The recombination epoch marked the point where the universe cooled enough for free electrons to combine with protons, forming stable, neutral hydrogen atoms. This crucial event is what allowed photons to travel freely for the first time, creating the cosmic microwave background. Super-Earths are a common class of exoplanets in the void worlds that are more massive than Earth but significantly less massive than Neptune. Their prevalence and diversity suggest that planetary formation processes are more varied than previously thought. The Hubble Ultra Deep Field Image captures a tiny patch of the void, revealing thousands of galaxies, many of which are seen as they existed just a few 100 million years after the Big Bang, offering the deepest look into cosmic history achieved through visible light. Stellar streams are long, thin, trailing formations of stars that were once part of small satellite galaxies or globular clusters, violently torn apart and stretched by the immense tidal gravity of a larger host galaxy as they orbit through the void. The concept of dark energy density being constant means that as the overall volume of the void increases, the total amount of dark energy also increases, driving the acceleration of the universe further. It is a mysterious, anti-gravitational energy intrinsic to space itself. Eclipsing binaries are star systems in the void where two stars orbit each other in a plane that causes one star to periodically pass directly in front of the other, causing a measurable and periodic dip in the total light observed. The Lagrange points are 5 specific positions in the void near to large orbiting bodies, where the gravitational and centrifugal forces balance perfectly. These stable points are ideal parking spots for space telescopes and future space stations. Cosmic background neutrinos are the equivalent of the CMB, but for neutrinos. These incredibly cold, ghostly particles were released a few seconds after the Big Bang and silently filled the void, though they are much harder to detect than photons. The process of outgassing describes how volatile materials like water vapor and carbon dioxide are released from a planet's interior through volcanic activity, contributing significantly to the formation or continuous replenishment of its atmosphere in the void. Let the vast, silent, and ancient nature of the cosmos soothe your soul entirely. There is a deep, eternal continuity in the void that invites perfect stillness. Rest your thoughts on this great stability and slip into deep, restorative sleep. The solar cycle is the crucial 11-year period during which the sun's magnetic field completely flips its polarity. This powerful cycle significantly impacts the solar wind and the rate of coronal mass ejections launched into the void. Dwarf galaxies are small, faint galaxies containing only a few billion stars, a tiny fraction of the Milky Way's size. They are the most common type of galaxy in the void and are frequently found orbiting as satellites to much larger, more massive galaxies. The magnetosheath is the region of the void between the bow shock and the magnetopause of a planet. Here, the solar wind is dramatically slowed, compressed, and heated before being largely deflected around the planet's magnetic shield. Brown dwarfs are objects too massive to be considered planets, but too small to ignite sustained hydrogen fusion like true stars. They occupy the intermediate mass space in the void, slowly cooling off after a brief period of deuterium fusion. The Chandrasekhar limit defines the maximum stable mass of a white dwarf star approximately 1.4 times the mass of the Sun. If a white dwarf accretes enough mass to exceed this limit, it will violently collapse, resulting in a catastrophic type Ia supernova. Rogue comets are comets that have been violently ejected from their original star systems and now drift silently through the vast interstellar void. They offer a unique possibility of carrying life-supporting water and organic molecules across the galaxy. The Virgo supercluster is the vast collection of galaxies that contains our local group and the Milky Way. All these millions of galaxies are gravitationally linked, slowly moving together through the immense cosmic void. The KT boundary in Earth's geology marks the catastrophic impact event of an asteroid or comet 75 million years ago, a stark reminder that the seemingly empty solar void can occasionally send devastating visitors. Superfluidity, a quantum state where matter flows without any friction, is theorized to exist inside the cores of neutron stars, providing another example of exotic physics hidden deep within the superdense objects of the void. Let the gentle, rhythmic turning of the Earth and the slow, inevitable expansion of the void synchronize your breathing. There is no resistance to the cosmos, only flow. Feel the peaceful weight of your body and sink into sleep. The Hubble sequence is a morphological classification scheme for galaxies in the void, grouping them into ellipticals, spirals, and irregulars based on their visual appearance. This sequence attempts to chart the observed evolutionary paths of galactic structures. Exomoons, moons orbiting exoplanets, are theoretically common throughout the void. Detecting these satellite worlds is a major goal for astronomers, as large moons could stabilize a planet's axial tilt and enhance its overall habitability. The Sun's magnetic field extends far throughout the heliosphere, forming the Parker spiral. This spiraling magnetic structure is carried outward by the solar wind, influencing the movement of all charged matter in the local solar void. The bow shock is the distinct wave created in the solar wind when it encounters a planet's magnetosphere. It is the first point of interaction, where the supersonic flow of the solar wind is abruptly slowed down and compressed. Dust rings around stars are often observed in the void, formed by the constant collision and grinding down of asteroids and comets. These rings are definitive evidence of ongoing planet forming or destructive processes in a system. Molecular complexity in the void is measured by the number of atoms in a molecule. Astronomers have detected increasingly complex organic molecules, including those necessary for amino acid formation, floating in interstellar space. The dark ages of the universe refer to the time period after the CMB formation and before the first stars ignited. The void was simply filled with cold, neutral hydrogen gas and lacked any sources of visible light. Gravitational microlensing is a detection technique that uses the temporary brightening of a background star's light as a massive, foreground object passes in front of it. This method has discovered many rogue objects in the void. The Eddington limit defines the maximum luminosity a star can achieve before the powerful outward pressure of its own radiation becomes so strong that it blows away its outer layers into the surrounding void. The infinite depth of the void is a source of profound calm. Let your senses turn inward, away from the light and sound of the surface world. There is only the quiet certainty of the cosmos to accompany your rest. Stellar cannibalism describes the process where one star in a binary system strips material from its companion. This stolen mass can lead to stellar rejuvenation or trigger a violent supernova explosion in the void. The cosmic web is the large-scale structure of the universe, consisting of vast, thread-like filaments of galaxies surrounding gigantic, empty cosmic voids. Dark matter provides the gravitational scaffolding for this web. Icy dwarf planets like Eris and Haumea reside in the scattered disk and the Oort cloud. Far from the Sun, these distant worlds are essentially time capsules of the solar system's primitive, icy composition. The Hubble tension refers to the significant difference between the expansion rate of the void measured in the early universe and the rate measured in the late universe. This discrepancy points to potential new physics. Interstellar travel faces the challenge of vacuum friction, the slight drag caused by the very thin but present interstellar medium. Over immense distances, this subtle friction becomes a factor in spacecraft deceleration. Type II supernovae result from the core collapse of massive stars that have exhausted their nuclear fuel, exploding and scattering newly formed elements across the galactic void, enriching the gas for future generations. The Hertzsprung-Russell HR diagram is a fundamental scatter plot used to classify stars by temperature and luminosity. A star's position on this diagram reveals its age, mass, and current evolutionary stage in the void. The zone of avoidance is a region of the sky heavily obscured by the dust and gas within the Milky Way's disk. This thick interstellar dust prevents astronomers from observing the thousands of galaxies lying directly behind it. Cosmic background radiation extends beyond the microwave spectrum to include radio waves and even a low-level background of gamma rays, each frequency telling a different story about the energetic history of the void. Allow your mind to focus on the deep, enduring processes of the cosmos. The turning of time and the motion of matter are ceaseless, yet profoundly tranquil. Rest now, within the embrace of cosmic order. Extremophiles organisms that thrive in conditions previously thought impossible for life are of great interest to astrobiology, suggesting life might survive the harsh radiation and temperature extremes of the void. The cosmic year is the time it takes for the Sun to complete one orbit around the center of the Milky Way, approximately 230 million years. It puts the entirety of human history into a vast, galactic perspective. Relativistic aberration is the apparent change in the direction of light coming from distant objects due to the observer's high velocity. This effect subtly shifts our view of the void during high-speed space travel. White holes are hypothetical time-reversed black holes, regions in the void from which matter and light can escape, but nothing can enter. They are mathematical curiosities, but their existence is highly unlikely. Planetary rings are not permanent structures. They are constantly being reshaped, supplied by debris from moons, and eroded by gravity and micrometeoroid impacts, silently evolving within the local void. Stellar nurseries, or nebulae, are not randomly distributed. They often form along the shock fronts of spiral arms, where gas and dust are compressed by density waves sweeping through the galactic disk. Gamma-ray bursts are the most powerful explosions in the universe, briefly outshining entire galaxies as energy streams into the void. They are caused by the collapse of hypermassive stars or the merger of neutron stars. Space weathering is the slow erosion and alteration of exposed materials caused by bombardment from solar wind particles and micrometeoroids in the near-perfect vacuum of the void. The local group is the cluster of over 50 galaxies that includes the Milky Way and Andromeda. All are gravitationally bound, slowly moving through the intergalactic void, destined to eventually merge. The silence of the void is absolute. Let that silence enter your mind, extinguishing the noise of daily life. There is nothing left to do but breathe slowly and allow yourself to sink into the quiet, deep peace of sleep. The escape velocity is the minimum speed an object needs to break free from the gravitational influence of a massive body. It is zero in the true void, but defines the boundaries of planetary and stellar systems. Exocomets orbiting stars other than the Sun have been detected in the void. They are prime candidates for transporting water and organic materials to newly forming exoplanets, aiding the potential for life. Hyperbolic trajectories describe the path of an object moving so fast that gravity can only deflect its path. It never completes an orbit. These non-repeating paths are common for interstellar visitors passing through our system. The cosmic dark fluid is a speculative concept suggesting that dark matter and dark energy are two manifestations of a single unified fluid, simplifying the explanation for both the structure and expansion of the void. Dust opacity refers to the degree to which interstellar dust blocks light. This opacity is highest in visible light and lowest in infrared light, which is why infrared telescopes are essential for peering into dusty star-forming regions. Plasma acceleration is a phenomenon where magnetic fields propel charged particles to extremely high energies, creating cosmic rays that zip through the void. This process is often seen near supernova remnants. Stellar mass loss occurs when stars shed material through stellar winds and flares. This expelled matter enriches the interstellar medium, ensuring the next generation of stars is born with the elements needed to form planets. The cosmic parallax method is used to measure the distance to nearby stars by observing their apparent shift in position as the Earth moves around the Sun, forming the baseline for the entire cosmic distance ladder. Interplanetary dust particles, sometimes called cosmic dust, are constantly raining down on Earth. These tiny fragments originate from comets and asteroids and represent ancient, pristine material from the solar void. Find comfort in the relentless, silent march of cosmic time. Eons pass, galaxies merge, and stars are born and die, all without hurry or stress. Let the massive scale of the universe reduce your concerns to insignificance. The Great Rift is a dark band running through the Milky Way's central plane, caused not by a lack of stars, but by thick, intervening clouds of cold, non-luminous gas and dust that block our view of the galactic center. Typia supernovae are triggered when a white dwarf accretes enough mass from a companion star to exceed the Chandrasekhar limit, collapsing and exploding with a uniform, standard brightness. The magnetotail is the elongated tail of a planet's magnetosphere, which is stretched away from the Sun by the solar wind. It is a region of complex magnetic activity extending far into the void. Ablation is the erosive process where high-speed heating melts or vaporizes the surface of a meteoroid as it plunges through the atmosphere, a protective mechanism against fast objects from the void. The gene's instability is the condition under which a cloud of gas in the void becomes gravitationally unstable and begins to collapse, marking the first step in the formation of new stars and star clusters. Radio bursts from Jupiter's magnetic field, caused by the interaction with its moon Io, are strong enough to be detected by ground-based radio telescopes, an audible sign of planetary activity in the void. The stellar graveyard of the Milky Way is thought to contain billions of dim white dwarfs, neutron stars, and stellar mass black holes, silently orbiting the galactic center, remnants of countless bygone suns. Planetary obliquity, or axial tilt, is the angle between a planet's rotational axis and its orbital plane. This tilt is crucial for seasons and climate stability, making it a key factor in habitability. The Cosmic Background Imager experiments provided high-resolution measurements of the CMB, revealing subtle temperature variations that confirmed the existence of dark matter and dark energy. The vastness of the void holds no secrets from the patient observer. Let the quiet consistency of these cosmic facts settle your mind. Relax your body and surrender to the deep, silent current of the night. Degenerate matter is a highly compressed state of matter found in stellar remnants, where the density is so high that quantum mechanical effects, rather than heat pressure, support the object against gravity. The E-type galaxies' ellipticals in the void are typically massive, lack significant gas and dust, and have very little ongoing star formation, representing the ancient, settled structures of the cosmos. Spectroscopy is the study of the light emitted or absorbed by objects in the void. It allows astronomers to determine an object's chemical composition, temperature, velocity, and density from millions of light-years away. The cosmic horizon places a fundamental limit on how far we can look into the void, defined by the finite speed of light and the finite age of the universe. We can never see beyond this boundary. The heliopause acts as a giant bubble surrounding our solar system, partially protecting the inner planets from the higher energy galactic cosmic rays that permeate the true interstellar void. The baryogenesis period refers to the time in the early universe when a slight asymmetry between matter and antimatter resulted in the survival of matter, forming all the structure we see today. Exoplanet transits are observable dips in starlight caused by a planet passing in front of its star. The duration and depth of this dip provide key information about the planet's size and orbital period. The Poynting-Robertson effect is a subtle force where starlight causes small dust particles orbiting a star to slowly spiral inward. This effect constantly cleans the inner void of a solar system. Cometary tails always point away from the Sun, regardless of the comet's direction of motion. This is because the tail is pushed by the pressure of the solar wind and light streaming into the void. Feel the unyielding forces of gravity and time guiding the universe. This great cosmic order is a source of profound security. Let go of all resistance and let the inevitable motion of the cosmos guide you into rest. The tidal force exerted by the Sun plays a role in generating the Oort cloud and scattering icy bodies into the solar system's far-flung void, influencing the supply of comets to the inner planets. Molecular outflow is a process where newly formed, massive stars eject large streams of gas from their poles, clearing the surrounding stellar nursery and enriching the void with newly processed material. Dark energy is modeled as a cosmological constant, meaning its density remains the same even as the volume of the void increases. This unique property drives the accelerating expansion of space. Gravitational wave astronomy is a new field that detects ripples in spacetime caused by the most violent events in the void, such as the mergers of black holes and neutron stars, offering a new sense to observe the universe. Warp bubbles, as described by the Alcubierre drive concept, propose creating a localized distortion of spacetime that could allow a spacecraft to travel faster than light without violating physics locally. Tidal forces can sometimes heat up the interiors of moons, like Enceladus, to the point of maintaining subsurface liquid oceans, making these icy satellites prime targets in the search for life in the void. The local filament is the small, thread-like structure of galaxies within the cosmic web that connects our local group to the larger Virgo supercluster. We are moving along this thread in the emptiness. Stellar remnants, white dwarfs, neutron stars, and black holes are the final, dense endpoints of stellar evolution, silently populating the void after their nuclear fuel has been exhausted. The Doppler effect explains why light from objects moving toward us is blue-shifted, and light from objects moving away is red-shifted. This is how we measure the velocity of stars and galaxies across the void. The entire observable void is structured by fundamental constants: the speed of light, the strength of gravity, the mass of an electron. These constants provide the stable, unyielding framework for all cosmic reality. Sleep now. Active galactic nuclei are the extremely bright, central regions of some galaxies, powered by supermassive black holes actively consuming matter and radiating intensely into the void. Photodissociation is the process where high-energy photons in the void break down molecules into smaller fragments or atoms. This is a primary destructive force in unshielded interstellar gas clouds. The Sun's quiet zone is the inner core region where nuclear fusion occurs. This zone is shielded from the turbulence of the outer layers, providing the stable, persistent energy that illuminates our local void. The Cassini spacecraft used the Earth, Venus, and Jupiter for gravity assist maneuvers to gain the speed necessary for its journey to Saturn, demonstrating the power of precise orbital mechanics in the void. Planetary rings are believed to be primarily formed from the fragmented remains of moons that were destroyed by tidal forces or collisions, creating a broad, flattened disk of debris in the equatorial plane. The Great Nothing is a colloquial term for the massive, underdense regions within the cosmic web, emphasizing the startling contrast between dense filaments and the truly empty voids. The Cosmic Background Explorer satellite provided the first high-precision measurements of the CMB, revealing the tiny temperature fluctuations that seeded the formation of all structure in the void. Rogue planets may be detectable by the heat left over from their formation or through the gravitational microlensing effect they have on background stars as they silently pass through the galactic void. Hydrostatic equilibrium in the universe ensures that forces are always balanced. The outward pressure of heat and rotation is constantly balanced by the inward pressure of gravity. Let your body become heavy, a small mass anchored on a small planet, orbiting a single star. Feel the vast, quiet motions of the void above you and allow your consciousness to sink into a deep, dreamless rest. The mass-metallicity relation shows that more massive galaxies tend to have a higher abundance of heavy elements. This indicates they retained more of the gas and dust ejected by supernovae throughout their history. Molecular ions are charged molecules detected in the cold, sparse void. Their presence suggests that complex, low-temperature chemical reactions are being driven by cosmic rays and magnetic fields. The gene's mass is the minimum mass required for a cloud of gas in the void to overcome its internal pressure and collapse under its own gravity, initiating star formation. Tidal streams are a form of galactic debris composed of stars pulled from their parent clusters by tidal forces, forming ribbons of light that trace the paths of gravitational perturbation in the void. The solar neighborhood is the region of the void within a few hundred light-years of the Sun, containing thousands of stars that share a common motion and galactic environment.